Good morning. Let's start with some framing questions. We're on SAS 5, length of daylight. We're crossing the equator. We're going to look at the city of Porto Alegre in Brazil. Does the sun rise in the east in the southern hemisphere? You know, it rises in the east in the northern hemisphere. Is that different down there? Is it warmer in the southern hemisphere during July? Or is it warmer in December? And how do you know? So let's talk about good things. Spring break is Friday. Groovy. Going to have some time off. I'm going to be building an addition to my domicile, and hopefully I'll be putting a porch on really soon too. In the meantime, hey, cool things. Let's keep going. So in the last couple of assignments, we've investigated the relationship between a city's latitude and the length of daylight it experiences throughout the year. And we did so by making scatter plots and finding a regression model for the functional relationship between the day of the year and the length of the daylight for 3 different cities at 3 different latitudes in the northern hemisphere. Houston, Texas at 30 degrees north, Philadelphia, Pennsylvania at 40 degrees north, and Winnipeg, Manitoba, Canada at 50 degrees north. Now, in this activity, we're going to investigate a relationship between 2 cities that are the same distance from the equator, 30 degrees from the equator, but they're on opposite sides of it. Houston, Texas, in the northern hemisphere, 30 degrees north, and Porto Alegre, Brazil, which is in the southern hemisphere, 30 degrees south of the equator. I remember Porto Alegre, Brazil, is located in the southern hemisphere at 30 degrees south latitude. Houston, Texas, is located in the northern hemisphere at 30 degrees north latitude. How do you think the graphs of the length of daylight by day would compare for the 2 cities? Now, we looked at the one for Houston, and we know exactly what it looks like. But let's look at it. No, let's just think about it. How would you predict it? Now, I can't answer this for you, and I'm not going to speculate what you might think, but you know it's going to be different because they're not in the northern hemisphere. It's in the southern hemisphere. Okay, but let's look at it. Let's make a scatter plot of the length of daylight by day number for Porto Alegre on the blank grid provided in class. Now, you can do that on paper, or you can use a model from Desmos. So we have the day number here for both cities, and the minutes for Houston elapsed during the sunlight hours, and for Porto Alegre, here are the minutes elapsed for the daylight hours. So let's look and see what that does. Now let's recall the graph for Houston's minutes of daylight for the year. We start down here, and we're going to move up and drive closely over the top. That's Houston, all right? Now, we're going to add the Porto Alegre minutes of daylight scatter plot to the graph. Notice that it doesn't start at the same spot, and it doesn't even curve in the same spot. Do you see that? That's because it's nowhere near the other one. How does the scatter plot for Porto Alegre compare to the scatter plot for Houston? Does it match your prediction? What did you predict it to be? Why do you think this is so? What do you think it doesn't match? It's pretty simple to think. We're going to use Desmos to generate a sinusoidal regression model for the Porto Alegre data and record the equation, round values to 2 decimals. In the summary table, factor the value of B from the quantity, Bx minus C, and include that form from the equation as well. Now, I'm going to graph my regression model here, and this is the one I've done. It's not perfect, but you get the idea. So, how do the regression models for Houston and Alegre compare? Let's look at it. Wow, they're opposite. I mean, I think that's what it says too. The similarities, they're shaped the same. They have the same maximum and minimum. They reflect each other. That's a difference, and one goes up and the other goes down. Let's take a look at what that means. Yeah, one's going down while the other's going up, and then when the other one's going down, it's going up. The maximum and the minimum are in 2 different spots. So let's take a look at what we can say about that. We're determining the minimum and maximum of the graph by simply right-clicking near the highest and lowest point. The result will be the coordinates for both. So I'm going to take you to my Desmos. Here from the quantity is my Desmos for Houston. At the maximum, if I click on it, it's going to give me a point. That's going to give me the maximum. If I come down here and look, it actually highlights and it gives me the lowest point too. As a matter of fact, if I click on this one, it also gives me the minimum and maximum, okay? So now you know how to get a maximum and minimum on a Desmos function. or a Desmos computer. And how does the maximum length of daylight for Porto Alegre compare to the maximum length of daylight for Houston? It's almost the same for Houston, but it occurs on the day that Houston has the minimum length of daylight. Minimum, how does it compare to the minimum length of daylight for Houston? It's the same in both cities, but guess what? The minimum occurs on the day that Houston has the maximum. The minimum in Porto Alegre occurs on the day that Houston has the maximum length of daylight. Now, we can do the same thing with the intersection points on Desmos, and I'm going to show you real quick. If I go here, it shows the intersection points. And if I click on them, it actually gives me those values. What do these intersection points mean in the context of the situation? Recall that the scatter plot shows the order of pairs, day number, and length of daylight for both Houston and Porto Alegre. They represent the days when the length of daylight in both Houston and Porto Alegre is the same. That's what those intersection points mean. Now, how do the intersection points of the graphs of Houston, Philadelphia, Winnipeg, and Porto Alegre compare? And what do these points mean in terms of context of this situation? So all four graphs intersect near the same 2 points, the spring and autumnal equinox. On both of these days, the length of daylight for all four cities is about 12 hours, which is exactly the same amount of hours of nightfall. Now, I want you to consider this. In Porto Alegre, if it is spring in Houston, what season is it in Porto Alegre? It's obviously the opposite. It's going to be fall. And if it's fall in Houston, what is it in Porto Alegre? It is spring. All right. So what would you expect the scatter plot of the length of daylight by day to look like for a city like Quito, Ecuador, lying on the equator? And why do you think this is so? So I'll give you a moment. It's pretty simple. A scatter plot or curve of Quito's daylight would likely look more linear than sinusoidal, as the change of daylight hours from minimum to maximum is very close to the same length. All right, I'll launch you the same way, folks. There's going to be a lesson in the Google Classroom. Take a look at it. Do the assignment really quick. Be prepared to come in Friday, get on the computer, and turn in all the work you've done on the sheets of paper for the project. This is a major grade coming in. However, don't forget to go in the Google Classroom and do the assignment for this specific lesson, crossing the equator. Take care of yourself. Be blessed and be a blessing.